Why do we even care about subnetting? Uh, by the way, we have already talked about these classes, um, then the ranges and these everything. So why even do we care about subnetting? If I give you example of these two routers, how many networks do we have here? We have only one network, this. And how many hosts do we need? We have two hosts, this and this. In a plain English, what I'm trying to say here, we have one network. Let's suppose 192.168.1.0. Then we have to provide the host IP, which is host ID, which is, let's make it 1 and 2. So it means the IP address for this router is 192.168.1.1, and for this one is 192.168.1.2. But if I correlate with the host per network or the possible number of networks, you can see how many hosts we can consume on class C, because this is now from experience we know 192 comes into the range of class C. Class C can accommodate how many hosts? 254. Okay, how did we calculate this 254? By the way, if I will show you the calculator, just a minute. We know this class C, how many what is the subnet mask of class C? 255.255.255.0. Okay, this represent how many bits? 8 bits. Okay, if we do 2 raise 8, which becomes what? If I do 2 raise 8, 256 host. Okay, but we always do minus 2, which becomes 254 host, means total number of 254 IP addresses we can provide on class C, which we were using here. Let's say this is 192.168.1.x, and this is .1, .2. Similarly, we can provide .3, .4, .5, .6, .7, all the way to .254, which I have mentioned here, this one. But don't you think that we are wasting these IDs? Okay, because we have consumed only 2. If we have another router here that is on totally different network, we cannot assign the same IP scheme here as well. Even if you will try to, it will give you an error that the address is overlapping. So just imagine we are wasting so many IP addresses for nothing, and even 3 as well. Okay, so we are consuming only 1 and 2, the rest are we are wasting. So this is where subnetting helps us. Subnetting will divide into in the next slide. I guess we are going to talk about that a lot in detail. So here I have mentioned, so how many numbers of network and host requires in such case. So if I'll ask you, how many networks do we have here? We have 1, 2, 3, 4, and 5. So we have 5 networks. So it's mentioning, so how many numbers? I have mentioned 5. Same IP address cannot be used for all networks, but different IP scheme can. Means, for example, if earlier I was talking about the class C, which is 192.168.1.x. Let's suppose I have consumed 192.168.1 for this one. Okay, the same dot 192.168.1 I cannot use here, I cannot use anywhere. I need to provide a different network, which could be what, 192.168, instead of 1 we could have 2.0. Now we can have dot 1 and dot 2 the host. Similarly here dot 1 and dot 2. So it means we should have the different networks, network ID for two different network from the same class C. But I have already given you example. We are wasting around 255 minus 1234, which becomes 251. So we are wasting 255 addresses here as well and here as well. So this is the basic requirement. We do not want to waste our IP addresses. So this is where we use the concept of subnetting, which we will do in earlier slides.